So hello everyone, let us solve another LeetCode problem, and the problem name is maximum sum of edge values in a graph. So let us read the problem statement first. So you are given an undirected connected graph of n nodes numbered from 0 to n minus 1. Now each node is connected to at most two other nodes. So these are two important things: undirected connected and at most two other nodes. We will make use of it, and this is the most important observation in the question. On basis of this observation only we can solve this question in very easy manner. So let us read the further problem. So they are saying that the graph consists of m edges represented by the normal 2D array which we have of edges, where edges of I is nothing but ai comma bi, which indicates edge between both of them. Now your task is to assign a unique value from 1 to n to each and every node. Now the value of an edge will be nothing but the product of values assigned to the two nodes it connects. So we'll understand what this problem says, but first of all what the question is all about. So let us read that first. Now your score is the sum of values of all edges in the graph, and then you need to return the maximum score that you can achieve. Now the most important thing that you can also see in the constraint is the graph is connected, which we have seen here as well, and it can have at most two other nodes connected to it. So these are the two important things. But first of all, let us understand what question actually means. So let us take this second example first and try to understand the problem statement, then we will find some solution out of it. So this is the second example by which we will understand the question, and then we will see how to find the solution. So this is the second example, and this is the graph that is being provided to us. Now they have assigned the values, so this is not a concern right now. We just want to understand the question, what it actually wants us to find out. So they have already assigned the values. So let's say for node 0 they have assigned value 3, for node 2 they have assigned value 1, for node 4 they have assigned value 2, for 5 they assigned 4, for 1 they assigned 6, and for 3 they are assigned 5. Now what is our task? Our task is to maximize the score. This is our main task. Now what is score? Score is nothing but sum of all values in the graph. Now you might ask, what is value? What is value? So they have said that value of an edge will be nothing but the product of values assigned to two nodes that it connects. So what does it mean? So for example, for node 0 and node 2, this is the edge. So the value of edge is nothing but the values to both of these nodes that they have, their product. So the value of this edge will be nothing but 3 cross 1, that is equal to 3. Let us take another scenario. This is the edge we are talking about. So this edge is connecting two nodes 1 and 5. So what is the value of this edge? The value of this edge is nothing but 6 cross 4, the product of these two values, which is nothing but 24. So we need to find the maximum score possible in order to solve this question. Now to achieve this maximum score, we need to assign these values to this node optimally. So we need to assign the values to nodes optimally. So we will see that how this thing we can achieve. But so let us just dry run this second example by how much we have understood this question so far, and let us see, are we understanding the question in the right way, if and we can achieve this output 82 or not. So let us dry run this basic understanding of the question. So our task is for now easier. We need not to worry much about how we will place these values optimally. For in this case we just need to figure out are we understanding the question in right way or not. So they have already assigned the values, we just need to check are we getting output as 82 or not. So let us find the values of each and every edge. So for this edge the value will be 3 cross 1, which is equal to 3. For this edge the value will be nothing but 1 cross 2, that is equal to 2. For this edge the value will be nothing but 2 cross 4, which is equal to 8. For this one the value will be 6 cross 4, which is nothing but 24. For this edge the value will be 5 cross 6, that is equal to 30. And for this one the value will be 5 cross 3, which is equal to 15. So these are the values which we are getting. Now we need to just check the score. So score will be nothing but summation of all these edges. Score will be like 3 plus 2 plus 8 plus 24 plus 30 plus 15. So like if you will calculate this you will be getting 82 as our output, which is matching this. So yeah, we have understood this question in the correct way. Now our task is to place these values like this 3, this 1, this 2 in optimally so that we can maximize this score. So let us see how we can do this or how we can find some solution for this problem. Now before understanding how to place the values optimally, when I was like reading the problem statement, I have said two important things. Those two important things were connected graph and at most two edges from a particular node, from one node. So what we can interpret from these two statements? Now if we have a connected graph and we can have at most two edges from one particular node, so there can be only two possible scenarios. Either that particular graph will be a kind of linear graph or a simple path, you can say simple path, or that graph could be a cycle. We can't have any other scenario other than the simple graph or cycle based on the two conditions that they have provided in the question. And this was the most important part of the question if you have understood this right now. Now it is very simple. Simple path is also connected, cycle obviously it is connected, and in both of the scenario the each and every node will have at most two edges, at most two, not more than two. So we can only have these two kind of scenarios. Like if we read the problem statement very carefully. So this was the most important thing. So we need to think in these two kind of scenario only. Now let us take this second example and try to like place these value optimally and how we can approach it further. Now we can put values from 1 to n. So 1, in this case n is nothing but 6, so we can have possible set of values which we can assign is 1, 2, 3, 4, 5 and 6. Now if we want to maximize the score, that means the sum or the product of all the like the sum of all the product, we need to maximize that. That means we need to have maximum product as we can build. So we will obviously choose the higher value first and try to place its neighbor as high as possible. So let us say we are taking 6 right now. So let us say I am placing 6 here. So in order to get the maximum product possible, I will place either 5 here and 4 here or 5 here and 4 here, whichever scenario you can take. So let us take 5 here and 4 here. Now there can be no possible scenario in which we can get higher value of this edge and this edge rather other than these other than these three values. You can try it out, you will understand why this thing will work. Now we will come on to this particular node. Now in order to get the maximum value of this edge, we need to take the next greater element which is possible for 5 to get the maximum product. Now what does that mean? We have utilized the 6, we have utilized 4, we have utilized 5. Now in order to get the maximum product of this particular edge, we need to multiply 5 with at most value possible, and in this case we have utilized these three values, so at most possible value will be 3. So we will assign 3 to this particular node. Now let's say we come across this 4. So in order to maximize the product of this edge, again we need to have 4 multiplied by at most value. So 3 is also occupied till now. So what is the at most value that we can get? It is nothing but 2. So 4 will be multiplied by 2. So we will assign 2 to this particular node. Now the only remaining value is 1. So we will assign 1 to it. So this is the most optimal way by which we can assign values to all the nodes. Now let us see if we are even getting the correct answer or not. So the value of this edge will be 3. Value of this edge will be 15, value of this edge will be 30, value of this edge will be 24, value of this edge will be 8, value of this edge will be 2. Now we will just sum all this up, so our score will be nothing but summation of all these values. So 30 plus 24 plus 15 plus 8 plus 2 plus 3. Now if you sum all this together, you will get 82, and if you remember, 82 was our output also. So this is our final answer, and by this way we can optimally place all these values to each and every node. So we have seen this particular approach in the drawing explanation part, but the next problem is how we will code it. So code is also very simple. We will follow exact same steps that we have seen in the explanation part. So what we have seen in the explanation part, first of all, your maximum value will get multiplied by the other two maximum values which are lesser than this particular value. So initially, let's say we are storing some answer variable which will be 0 initially. So first of all, before our iteration start, we will increment our answer by nums of n minus 1 multiplied by nums of n minus 2. That means 6 get multiplied by 5. Also we need to multiply 6 with 4. So we will again write one more step, nums of n minus 1, that is 6, gets multiplied by nums of n minus 3, which is nothing but 4. So this was the initial step. Sorry for that. So this was the initial step before our actual process start. We will do it before itself. So this was the first step for our code. Now what we will do next? Now we have seen that the edge values for the nodes which is connecting with node 6. Now we need to compute for all the other node values. So next node will be 5. So we have seen that 5 will get multiplied by 3, then 3 gets multiplied by 1. Because obviously if we have 6 here, we have 5 here, and we have 4 here initially. Now what is the next value for 5 maximum possible? It is 3. So 3 gets occupied here, 4 gets multiplied by 2, and we have remaining 1. So that means 3 will now get multiplied by 1. So 3 and 1 here gets multiplied. So it will kind of keep on going. One element gets skipped and it will get multiplied. So 5 skips one element, then multiplies it with 3. Then 3 skips one element and gets multiplied by 1. Now if we have completed this iteration, so initially our pointer was here, then it computed for the product for all the edges, so it get exhausted, it got out of bound and all of that kind of stuff. Now we will again set this pointer to here because we have not computed values for this. So now what we will do, 4 gets multiplied by 2, and since it is nothing left here, so we will end here. So what we will do, initially we will set our I pointer to n minus 2, and like we will run a for loop, or rather I should say a while loop, until our I minus 2 is greater than or equal to 0. Why minus 2? Because we are skipping one element. So like let me just and what we will keep on doing, we will just increment our answer by nums of I multiplied by nums of I minus 2, and this will keep on happening. Once this whole iteration gets completed, we will again set our I pointer to n minus 3, and this whole process gets repeated again. So this was the code part if we have graph as cycle. But wait, we are missing one more thing here. What we are missing one thing here is that if you observe this particular cycle carefully, we have multiplied 5 with 6 with 5 and 6 with 4. So 6 with 5 is done, 6 with 4 is done. Then we have started our pointer with 5, then we have skipped one element and keep on multiplying. So 5 gets multiplied by 3, so this edge is also done. Then 3 gets multiplied by 1, so this edge is also done. Then we have started our pointer from 4, and then one element skipping, we have just multiplied again. So 4 gets multiplied by 2, and since there is nothing to the left of 2 by skipping one element, we have just stopped our iteration. But wait, we haven't counted the product for this particular edge. So that means, now why this happened actually, because this is a cycle, so these two elements also get connected. So that means your first element and second element also gets connected in the end. So in the end, what you need to do, you just need to take nums of 0 multiply by nums of 1 and increment to your answer. So this is one additional step that is there in the cycle part, which is not present in the simple path, which we will see next in the further upcoming part. So I hope you understood this, how we are putting these values optimally and how we are getting the maximum score possible. Now this was for the cycle part. Let us see now for the simple path. So we will take the first example and see how we can optimally maximize our score in this simple path, which is our second scenario. So this is the second scenario where we have this simple path. So this is the first example where the graph is like this, and we have the possible set of values from 1 to n, where n is the number of nodes in the graph. So 1, 2, 3 and 4 are the possible values which we can place onto a particular node. So let us see how we can optimally put these values in order to maximize our score. Now what obviously we'll be starting from the maximum value only, but now what do you think, on which node we should put this value for? Either we can put it on some like end node, or we can place in some kind of middle node. Where should we put? Just question yourself, and your answer should be nothing but we need to place this 4 as mid as possible. Now why it is so? Because if we put maximum value in the middle, we have more scope to put as large value towards its right as well as towards its left. Now this is a very small graph. Let us say if we have some kind of graph like this. I'm not taking some values. I am just drawing like a very long graph of these many nodes. So this is these are I'm just drawing a random graph. It has just to explain why I am taking the middle part, or why I am placing the maximum value in the middle, why not onto some edge or on some particular or some different node value. Now let us say I have just drawn some like this random simple path graph. Now why I am saying that I should put maximum value into middle, in this case this middle is here, because if I put 11 here, I have more scope to put large value as possible towards its left and right. If I have put like 11 here, I have no scope to its left, I have only scope towards its right. If I have put value here, I have less scope towards left, I have more scope towards right. But this is the most optimal place in which I have as much scope as to put values towards its right as well as towards its left. Now this particular place will give us max product as possible, because I can put 10 here, 9 here, 8 here, 7 here. But if I have 11 put onto here, so I will have 10 here, 9 here, 8 here, 7 here, and so on and so forth. So here I will have a product as 110, here I will have product as 90, here I will have product as 72, here I will have product as, let's say, like 56. But if I have put 11 value here, I will have product here as 110, here as 80, here I will have as 90, here I will have 63. And if you go on and to all the values, you will realize that this green part sum will be larger than this blue part sum, because we have more scope towards left as well as right to put as max values as possible. So this is the analogy behind why we are putting maximum value as mid as possible. Now what do you mean by as mid as possible? Because if you have, let's say, even number of nodes, so either you can put maximum value here or here. So that doesn't matter, because we will write algorithm in such a way that wherever you put your answer will be same in both the cases. So let us now again move on to our example test case and understand that particular part. So this was our example, and let us say we have put our 4 value as here. So now again we will do the same step here. We will multiply the 4 with its nearest 2 neighboring elements. So 4 will get like multiplied by 2 here and 3 here. Now why we have put 3 here and not here? Because we have less values towards right and we have more nodes towards the left. So we are putting the maximum value where we have more number of nodes rather than less number of nodes. So that's why we have put 3 here and not here. Now this scenario was not occurring in the cycle because obviously it is cycle, so it will get connected. So like you understood that particular scenario. So let's say we have put 3 here and 2 here. So the only remaining value is 1. So we'll put 1 here. Let's say if we have some other scenario, 0, 1, 2, 3, 4 and let's say 5. let's say we have this simple path. So the possible set of values would be nothing but 1, 2, 3, 4, 5 and 6. So we will again put 6 here. Then we will obviously multiply 6 with its two neighboring elements. So 4 will be here, 5 will be here. We are putting the larger value here because here we have no more number of nodes rather than here which are less number of nodes as compared to this part. So we will put 5 here and 4 here. Now we will do the exact same part as we have done in the cycle graph example. We will multiply 5 with 3, then we will multiply 3 with 1. So 5 will get multiplied by 3, 3 will get multiplied by 1. So these nodes will be put onto 1 and 0 respectively. Now we will do the again same part. We will take our iterator to 4 and then we will skip one element and multiply it with 2. So we will again skip one element and now we have reached the end of the array. So we will not take any of the element. So this process is exactly same as what we have seen in the cycle example, but what is the difference here? In cycle part, the first and the 0th node and one node would have been connected because it was cycle. Now in this case it is not a cycle, so these two nodes, that is 5 and 0, will not get connected. So in the end, in the cycle part, what we have done, we have added answer by nums of 0 multiplied by nums of 1. So in this case of simple path, we will not do this. Other than that, everything is same as what we have seen in the cycle part. So I hope you understood this problem. It is a little bit tricky to understand if you have not dry run on some example test case, but if you dry run on one or two example test case, you will understand this analogy very clearly. Exactly similar approach what I have just told you right now, you will apply and dry run on some example test case. You will understand this question in more better way. So I'll highly recommend to dry run this particular algorithm for better understanding on some example test case by your choice, or some any other test case by just submitting your code and see some other test cases as well. So you'll understand in more better way. So let us directly jump onto the code now and understand this in with more clarity. And with code you will understand what I have just explained. The code is exactly similar to that. So let us see the code now. So this is our function of maximizing the score. So initially I have handled the edge cases separately. So if we have node with with only one node, then we will return 1 only, because since we will assign only 1 to that node. If we have node the number of node as 2, we will simply return 1 cross 2. That is obvious because there will be no other combination, because cycle will not be present in both of the scenario. Cycle is only present with at least 3 number of node. With 2 there is no cycle, with 1 also there is no cycle. So I have handled this edge case separately. Now we will see how the code flow works. So I have just taken the adjacency list. I have just created the adjacency list here. So adjacency list is created here. Then we are taking a visited array. Now why visited array? So first of all, we need to detect whether this particular graph structure is cycle or simple path, because based on this we have to add that particular extra condition in the end, by which we were multiplying nums of 0 with nums of 1 in the end. So if there will be cycle, we will add that condition, otherwise we will not add that condition. So we are simply running a DFS loop above which is shown. So let me just show you. So this is simple DFS code for like cycle detection. So what we are doing here, we are just we are just taking a visited vector and we are marking each and every element as we visit, and then we are moving to all of its neighboring elements. Now if that particular neighboring element is not visited, that means we need to continue our DFS until we visit all the nodes. And otherwise, what could be the particular scenario? If that particular node is not visited, then simply we are running a DFS loop. Other can be what condition? If that particular node is visited. Now again there can be two scenario. If that particular node is visited and that is its parent only, so that doesn't make sense, because let's say if we have this kind of scenario, we are coming from this node to this node and then we are again coming to this node, so that does not say anything about cycle. So if this particular condition hits, then we don't need to worry much about the cycle. Otherwise, if it is apart from its parent node, so let's say we come from here to here, then we come to here, from here to here, then we go from this node to this node, that means this node is visited again and this particular node is not parent of this node, that means it is a cycle, so we will return true. And in any of the DFS call, if we get cycle, from there also we can return true. After iterating all the nodes, after visiting all the nodes, if we did not detect cycle, we will just return false. So it is a simple DFS to detect cycle. You can just Google it, you will understand in more better way with a lot of finer presentations there. So you can check that too also. So after we have detected cycle, what we will do? So let me just come. Yes. So we have just created a nums array which will be containing node values from 1 to n, by which we will be multiplying to get our product. So initially we have seen that we have multiplied this last element with second last element and third last element. So the index of last element will be nothing but n minus 1, second last element will be n minus 2, and third last element will be n minus 3. So we'll multiply nums of n minus 1 with first n minus 2, then nums of n minus 1 with n minus 3. Now we will start iterating. So let us take that particular scenario only, 1, 2, 3, 4, 5 and 6. So we have multiplied 6 with 5 and 4. Now we'll be starting our iteration from 5. So initially our I will be pointing to n minus 2. So this is nothing but n minus 2th index. Now what we need to do? We need to skip one element and multiply it with next node. Again skip one element and multiply it with next node. So this while loop is doing this particular task only. Now what we have to do? We need to start at n minus 3th index. So this index is nothing but n minus 3th index, and we need to again repeat the same thing. Skip one element and multiply it with the next element. Skip one element and multiply it with next element until it reaches out of bound. So this is again also doing the same thing. In the end we are just checking one condition, if it is cycle or not. So if it is cycle, we are just adding one extra condition that we have seen in the drawing explanation part, that the two edges gets connected, so we need to take that product also. So we are just taking that product and adding it to our answer. In the end we are just returning that answer, and yeah, this is all about the code. So hope you understood this problem clearly. So thank you.